So, welcome to this lesson, and you are going to be questions and answers on fluid dynamics. So, they are going to be very short videos, which helps you to solve some questions, and there are going to be some few of them on their way coming. Okay, all right. So let's take a look at this question here. So it says that we should let phi of wxyz be the expression we have here, and b is equal to -5130. Then we are supposed to find these. So we find this, and that. And our answer should be to one decimal place. Right. So this phi of x that we have here means you are going to differentiate your function here with respect to x. That's then the b means after that you put in the values of b inside to get a value. Alright, so let's start solving it. So you realize that our phi of wxyz, the function, was given us this that we have here, and this was b. So the first one says we should find phi of w, which is the same as the partial derivative of our function phi here with respect to w. So we realize we are differentiating with respect to 0, so the whole of this will be 0. Then here, because you have w here, when you differentiate this, you're going to get x, and this will be 0 because you don't have any w here. So that means you're going to have phi w to be just x, and you realize that with the point, this is w, this is x, this is y, this is z. So x is equal to 1, so that means phi w of b will be 1.0. Then we go to phi of phi x, or the partial derivative with respect to x. So now we will come here, realize that there is an x here, there is an x here, there is no x here, so this part will go to 0. And when it comes to this part, you should know that we have a squared here. So you should remember when we are doing this differentiation, then we'll bring the 2 that we have here. Then we multiply everything by the expression that we have here. That's what you can see here. And you will come into the expression and differentiate whatever we had. So when you differentiate what is here, you're going to get negative yz. So that's what you can see here. Then when you come here and differentiate with respect to x, you get plus w. That's what you can see here. So you can simplify this further. It gives you this, right? Then when you put in the values of your, remember this is for w, this is for x, this is for y, and this is for z. So when you put in the various values, realize that since z is 0, the whole of this goes to 0. This goes to 0. So we have -5 here. But since the question said one decimal place, let's bring point 0. So it follows the same way. So with the phi of y, so you are going to find the partial derivative of your phi with respect to y, which is going to give you this as we have here, which can be simplified further to get whatever we have here. Then when you put in the value for b, you are going to get 0.0 because we have z here, which is 0, z squared here, which is 0, z is also 0. So it will make everything go to 0. So that means you're going to have 0.0. Right, when it comes to the last one, we have to find the partial derivative of our phi with respect to z. Right, so doing that is going to give us this as we have here. So all of them, we can reference our phi here. So this is our phi, right? You can reference it, and also reference the point b that we have here. Okay, so when you have this, then you can simplify it further to get this, which can be simplified further to get that. And when you put in the values for w, x, y, z, then that means you are going to get -2 1 times 3, then plus 2 1 squared times 3 squared times 0. So this portion goes to 0. Then 3 times 3 squared. So this is going to give us -2 times 3, which is -6. This will give us 3 times 9, which is plus 27. So when you do this computation, you get 21.0. So this happens to be the solution to that particular question. Thank you.